Finding the distance between two elements looks like it needs a nested loop search, but there's a single pass tracking trick that cuts the runtime drastically. The goal is simple. Given a list of words and two specific target words, find the shortest distance between them. Let's look at an example. Imagine we have a list containing practice, makes, perfect, coding, and makes again. If we're looking for the distance between coding and practice, we see coding is at index 3 and practice is at index 0. The distance is the absolute difference between those indices, which is 3. We need to return the smallest possible gap if the words appear multiple times. The intuitive way to solve this is to find every occurrence of the first word and then, for each one, scan the entire list again to find every occurrence of the second word. By calculating the distance for every possible pair and keeping the minimum, we get the answer. However, this nested approach results in a time complexity of O of n squared, which is far too slow for large datasets because we're redundantly scanning the same elements over and over. The key insight is that we only care about the most recent positions of our two words as we move forward. We start by initializing two index trackers to -1 and a minimum distance variable to the largest possible integer. As we iterate through the list once, we update the first tracker whenever we hit the first word and the second tracker whenever we hit the second word. Every time we update either one, if both trackers are no longer negative, we calculate the current distance and update our minimum if this new gap is smaller than what we've seen so far. Let's trace this with our example. We start with indices at -1. At index 0, we find practice, so our first index becomes 0. We keep moving. At index 3, we find coding, so our second index becomes 3. Now that both are set, we calculate the difference, which is 3, and set that as our minimum. As we hit the final word, makes, nothing changes. Our final answer remains 3. We found the shortest distance in one single pass without ever restarting our search. You'll recognize this pattern when you need to find the closest pair of elements meeting specific criteria in a linear sequence. The time complexity is O of n since we traversed the list once. The space complexity is O of 1 because we only store a few integer variables. Try the shortest word distance 3 problem next to see how this pattern evolves. Subscribe for more DSA deep dives.